Objective 3, using the linear factorization theorem to find polynomials with given zeros. Linear factorization theorem. If a polynomial of a standard kind is a polynomial with real coefficients where n is greater than 1 and a sub n is not 0, then the polynomial can be factored and with n maximum of n zeros, 1 to up to n zeros, because x was powered by n. So where c sub 1, c sub 2, c sub n are complex numbers, not necessarily real numbers. It's not necessarily all polynomial functions to be to have all zeros. It's possible some of them not to have real zeros. This means that an n-degree polynomial can be expressed as a product of non-zero constant and n linear factors where each linear factor has a leading coefficient of 1. Based on this theorem, find an n-degree polynomial with real coefficients satisfying the given condition. Well, the polynomial is going to be powered by 3, so 3 zeros. And I'm given 2 of them. First of all, where the complex factors come from? From the previous example, you saw that we had one real zero right here, and then we ended up having using either the square root property or using the quadratic function, we end up having plus and minus before the square root. So from there, there come 2 other solutions. Well, if it turns out that under the square root we have a negative number, so imagine x is equal to negative b plus and minus square root of some negative number, negative discriminant. Well, that negative discriminant is going to give me a complex number. And since it's plus and minus complex number, the complex numbers always come by pair. So provided that 2i is a 0, this means that x is equal to negative 2i is also a 0. So all zeros in this polynomial, since it's powered by 3, they need to be 3 of them. X is equal to 4, x is equal to 2i, and x is equal to negative 2i are all the 3 zeros. So what this means for this polynomial? Well, this means that the polynomial is going to look like some number. I can't claim what is this number exactly, but this number times x minus 4 must be a 0, must be a factor since 4 is a 0. X minus 2i must be a factor since 2i is a 0. And x plus 2i must be a factor since minus 2i is a 0. We can simplify to eliminate the complex numbers. So x times x is x squared. X times 2i is positive 2ix. Negative 2i times x is negative 2i times x. And negative 2i times positive 2i is minus 4i squared. Now the number I is equal to square root of negative 1. When we square both sides, I squared is equal to negative 1. So in this expression right here, I'm going to replace the I with negative 1. So f of x is going to be ax minus 4. Those two cancel, so x squared. And then we have minus 4 times negative 1 is positive 4. Alright, something else is given also in the polynomial. It's given if I plug in negative 1, the result is going to be negative 50. So I'm going to plug in negative 1. and see what's gonna happen. Negative 1 square is 1 plus 4, and the result needs to be negative 50. So that means negative 5 times a needs to be negative 50. It looks like a must be 2, this to be true. So my polynomial then look like f of x is equal to 2x minus 4 x squared plus 4. We can finish distributing here. That's x times x squared is x cubed, x times 4 is 4x, negative 4 times x squared is negative 4x squared, and then negative 4 times 4 is negative 16, and I need to times with 2. And I'm gonna put it in descending order because I don't have enough room. 2 times x cubed is 2x cubed, and I'm gonna multiply with 4x squared, that's negative 8x squared, and I'll go back to 4x, so that's plus 8x minus 32. That's my final answer. So we were able to find a polynomial that way. Example 7, very similar. It says look for polynomial power by 4 provided that one of the zeros is negative 2, the other zero is negative 1/2, and then I is also a 0. And as before, since I is a 0, we conclude that negative I must be also a 0, plus we are looking for 4 zeros for polynomial power by 4. Well, that means f of x is going to be some a times x minus 2 is plus 2, x minus 1/2 is x plus 1/2, and then x minus I times x plus I. I'm going to multiply one more time to remove the complex number. That's x times x is x squared, x times 1/2 is 1/2 x, 2 times x is 2x, and 2 times 1/2 would be 1. And here x times x is x squared, minus I times x minus xi, and negative I times positive I is minus I squared, where negative I squared, where I squared is negative 1. I squared is negative 1. All right. F of x is a x squared. Now 2x plus 1/2 x, we can write it as decimal if you prefer. 2 plus 0.5 is 2.5, or we can say that's 5/2 x plus 1, and then x squared minus I squared would be plus 1. Now we can plug in 1 to find how much is a. And plug in 1, we'll have a is equal to 1 plus 5/2 plus 1 times 1 plus 1. From here, a times, okay, so that's 5/2 plus 2 is 9/2. 9/2 times 2 needs to be equal to 18, or it looks like a is again 2. So the polynomial would look like twice x squared plus 5/2 x plus 1 times x squared plus 1. Well, I'll have to continue multiplying to find the final solution. X squared times x squared is x to the 4th. X squared times 1 is x squared. 5/2 x times x squared is 5/2 x cubed. 5/2 x times 1 is 5/2 x. 1 times x squared is x squared, and 1 times 1 is 1. And I'm gonna be combining and multiplying at the same time. So 2 times x to the 4th. Now I'm gonna go to the cubes. That's 5x cubed. Then x squared, and x squared is 2x squared. 2x squared times 2 is 4x squared. Then 2 times 5/2 would be 5x. And 2 times 1 is 2. So that's my final answer here. Find all the zeros of the polynomial function or solve the given polynomial equation. Use the rational zero theorem and the graph of the polynomial function shown by a graphing utility as an aid in obtaining the first zero of the first root. So if I'm gonna use a graphing utility, and I don't have it pulled up, where would that be? If I'm gonna use that, x power by 3, 7x squared plus 7x squared plus 11x minus 3. So that's the function. So what does this mean? Well, remember, I'm looking for the solutions or the x-intercept. So the x-intercept would be those values. And as you can see, some of the zeros are irrational numbers or fractions, which I cannot really find right away. But one of them is obvious, x is equal to -3 solution. And for this particular case, I didn't need to graph to see it, because if I look at P over Q, P is the factors of 3, which is plus and minus 1, plus and minus 3, and Q is 1, so Q is plus and minus 1. All possible zeros would have been P is equal to P over Q is equal to 1 divided by 1 and 1 divided by 3. So those are all possible zeros. And I might have checked with them only. However, now I'm pretty sure that x is equal to -3 is one of the zeros because I saw it on the graph. Of course, to be able to find the rest, we need to factor this polynomial. So use synthetic division, 1, 7, 11, and -3. Divide by -3. Bring 1 down. 3 times -3 times 1, -3. 4. 4 times -3 is -12. -1, and -3 times -1 is +3, so 0. So we were able to factor f of x to x plus 3, since -3 is 0, and the remaining part would be x squared plus 4x minus 1. So now we'll have to use quadratic formula to solve this part. A is 1, B is 4, and C is -1. So x is equal to -b plus or minus square root b squared minus 4ac all over 2a. Okay, so x is equal to -4 plus or minus 4 squared is 16, and -4 times -1 is +4, so altogether we have square root of 20 under the root over 2. And square root of 20 is the same as square root of 4 times 5. So I'll have to move that here to be able to finish my problem in a correct way. So that's the same as -4 plus and minus 2 divided by times square root of 5. Both of those are divided by 2. So altogether the last two zeros would be -2 plus and minus square root of 5. And we were able to find all three solutions. And the next question, find all zeros. We can help ourselves with graph, of course. The possible zeros would be multiples of 18 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, and plus and minus 18. See how many we have. So in this case it's handy to use the graph to help you out. Plus 7x squared minus 16. So here we have minus 16x plus 18 plus 18. Double check every time when you solve some function to make sure that you have you work with the correct graph. And I can see that the 0 here is gonna be at -9. So I'm gonna check with -9. Synthetic division 1, 7, -16 and 18. Check with -9. 1 times -9 is -9, minus 2, 18, 2 times -9 is -18, 0. So we were able to factor as x plus 9, again opposite of -9, and x squared minus 2x plus 2. We want to make that equal to 0. Again, we are going to use the quadratic formula. X is equal to, so A is 1 only for this part, B is -2, and C is 2. So x is equal to -b, -2, plus and minus square root b squared, -2 squared is the same as +2 squared, minus 4 times 1 times 2, all over 2a, all over 2. So x is -2 is +2, plus and minus. 2 squared is 4. 4 times -2 is -8. So we have under the root -4 over 2. Well, square root of -4 is the same as plus and minus square root of 4 times square root of negative 1, and square root of negative 1 is I. So here we go, we have complex solutions. 2 divided by 2 plus and minus 2I divided by 2, so square root of 4 is 2, square root of negative 1 is I, and we divide here to find the final two solutions. Two complex solutions coming by pair. The last example, find the zeros. One of the zero given, I can see that one of the zero is 1. So, and I'm gonna go synthetic division 2, negative 22, negative 18, 36. Try with 1. One times 2 is 2, 2 and 2 is 4, 1 times 4 is 4, minus 22 is negative 18, minus 18, negative 36, negative 36, 0. So we were able to factor by x minus 1. Now I can kind of see that this function goes down to negative 2 eventually. So I'm gonna check immediately with negative 2 to see if negative 2 is not by chance any 0. Again, drop. Notice that it doesn't make sense to start from the beginning. If I start from the beginning, I may figure out that negative 2 is a 0, but that doesn't help me reducing the power. Well, here that's power by 4, and I was able to reduce it to power by 3, and now hoping to reduce it to power by 2, which is nice. I can use the quadratic formula to keep solving. So it's better to continue. So bring the 2 down. Negative 2 times 2 is negative 4. 4 minus 4 is 0. 0 times negative 2. Negative 18. Negative 2 times negative 18 is positive 36. And it does turn out to be 0. So it looks like the next 0 here is going to be x plus 2. And the remaining would be 2x squared minus 18. So I end up having f of x is equal to. Notice that 2 can be factored out from those two terms. And if we factor the 2, we end up having x minus 1 times x plus 2 times x squared minus 9. Well, that's a well-known formula for a squared minus b squared to be a minus b, a plus b. So finally we're able to factor out this expression as x minus 1, x plus 2, x minus 3, and x plus 3. So we found 4 zeros, x is equal to 1, negative 2, 3, and negative 3. And with this, I'm concluding this lecture.